In this problem, we're going to get really close to drawing a full rational function. We're going to draw all the key features of the rational function. It's very difficult to actually do real graphing on the computer because of, the computer has a very hard time reading the swoops and curves that you put in there and actually marking it right or wrong. So the next best thing we can do is mark all these different key features, the y-intercept, the x-intercept, vertical asymptotes, and holes. And for this equation, what I want you to do when you're looking at something that is in unfactored form, first step, go ahead and factor that, because there's useful information to pull from both forms. And I can see that there's a greatest common factor of -3 here. And when I pull out -3, I get x squared plus 7x plus 12. Okay, on the bottom, I'm not going to change that yet. Let's just do one thing at a time. And now, let's factor that. Remember, the -3 stays out. On top, I have x plus 3 and x plus 4. On the bottom, I have, let's see, what is this going to be? I think that's x plus 3 and x plus 6. Okay, so here's our factored rational equation, which I'll just put right there. Now, we need to find all these different items here. First things first, the y-intercept. Okay, y-intercept. Where is that going to be in the graph? Well, remember where the y-intercept comes from. You evaluate the function where x equals 0. So if x equals 0, that's 0, that's 0, that's 0, that's 0. All you're left with is this at the end. So the y-intercept is just -36 divided by 18, which is -2. Okay, so we know something already. In terms of how you actually put that on the graph, I want to direct your attention to this little button right here. See that? That is for intercepts. So you would click that button, and then you would put your y-intercept right at -2. Okay? Now let's move on. Let's find x-intercepts next. Change the color. So to find x-intercepts, there could be more than one, I want to look at factors from the top of the equation. Okay, so here's one factor, which says x equals -3, and here's another factor, which says x equals -4. So you come over here, use that intercept button again, and we're going to say -3 and -4. Okay, those are really close to each other. So now I'm done with those. Let's look at, what did I miss? What did I miss? Got too excited. -3 is not an x-intercept. Does anyone see why? Right? Next thing we're looking for, we'll explain it. I want vertical asymptotes. Actually, not this next thing. We'll get to why x plus 3 is not an x-intercept. Hopefully you see it already. So the vertical asymptote from right here is x equals -6. Okay, that's this function, or this factor of the function. So we go over to x equals -6. And for this, I want you to draw a line on the graph. We're doing this one. And what you have to do is you select 2 points, like there and there. Just 2 points, and the graph will make a line appear connecting those 2 points. So there's the asymptote on the left. Now, the reason we don't have 2 asymptotes and 2 intercepts is because one of these factors right here is a repeat, this x plus 3. So x plus 3 is a repeat, and that tells us that there is actually a hole at x equals -3. Okay, so there is a hole in this function. And to figure out where that hole lives, we're going to have to go through a little bit of math here. So what you're going to do is you're going to write your simplified function. Okay, so I am going to get tired of this color real quick. Let's switch to darker green. -3, x plus 3, x plus 4. I'm just writing the whole function over again so I can see what cancels out. The other one was too cluttered. So I cancel out this x plus 3 term. And what's left? Just -3 times x plus 4 over x plus 6. Now into that, you're going to put this coordinate of the x value, the hole. So we say, what is f evaluated at -3? That's where the hole lives in the x coordinate. And that's equal to -3 times -3 plus 4 over -3 plus 6 And that's equal to negative 3 times 1, that's easy, over negative 3. Well, that's nice. Those cancel out. The result is 1. So that's the y-coordinate of the hole, meaning the hole's xy coordinates are negative 3 and positive 1. So you now use this button. See that open circle? That's how we designate a hole on a graph. It's different from a coordinate point. It's a place where the function does not exist. So we're going to go over to negative 3 and 1, and that is where the hole lives. And now I'm feeling weird because that doesn't look right. I think there's an error here. X plus 4, 1. Oh. Yeah, the error is I am an idiot and I can't add numbers together. Look back here. I said negative 3 plus 6 equals negative 3, and it doesn't. Ho ho, it equals positive 3, which means the result is at negative 1, not positive 1. Okay, so this hole exists down here. All right, so that's how you plot features of a graph on these windows.